The point P with coordinates 4, 4 lies on the curve C with equation y equals x squared over 4. Find an equation of the tangent to C at P, the normal to C at P. The point Q lies on the curve C. The normal to C at Q and the normal to C at P intersect at the point R. The line RQ is perpendicular to the line RP. Find the coordinates of Q. Find the x-coordinate of R. The tangent to C at P and the tangent to C at Q intersect at the point S. Show that the line RS is parallel to the y-axis. Okay, there's the question then. It's quite a long question and I've got it summarized here. So let's have a look at it then. So first of all, part A. We need the tangent and normal at P. So here's the function. P lies on C with these coordinates. So we need the gradient function then. Dy dx. Power rule, 2 comes down, 2 over 4 is a half, so it's a half x. And when x is 4 at P, put 4 in here, we get 4 over 2, which equals 2. So tangent then, y minus the y value, which is 4, is equal to the gradient of the tangent, which is 2, x minus the x value, which is 4. And that tells us then y is equal to 2x here, minus 8, move the 4 over to plus 4, minus 8 plus 4 is minus 4. So there's the tangent, part 1. Part 2, the normal, if the tangent gradient is 2, the normal gradient is minus a half. So do the same thing again for the normal, y minus 4, but this time the gradient of the normal is minus a half, isn't it? Because the product of these two things must be minus 1, because they're perpendicular. X minus the 4 again. And what does that give? Let's have a look. So that tells us then that y is equal to minus a half x. Minus times minus is a plus. 4 over 2 is 2. Move this over to plus 4, so it's plus 6. So there's the normal at P and the tangent and normal. Q is on C, so Q will have coordinates. If we write them parametrically, let's write the x coordinate as t. Now the y coordinate on Q will be t squared over 4, won't it? So t squared over 4. So there's the coordinates of Q because it's on C. The normals at P and Q intersect at the line R. So the normal at Q then, let's find the normal at Q. So the gradient of Q, the normal at Q then, RQ is perpendicular to RP. Okay, so the normal at P and Q intersect at R, so we'll do the normal at Q. So the gradient function is dy dx is equal to half x, as we said. So normal at Q has gradient then. Well, x over 2 will be minus 2 over x, wouldn't it, the gradient of the normal, and the x value is t. Okay, so there's the normal at Q. Right, now, so we've got the normal at Q, so what we could do, they meet at R, don't they? At R. So we could actually just write the equation of Q here, couldn't we? Y minus the y value, t squared over 4, is equal to the gradient, minus 2 over t, times x minus t. Okay, so what have we got there then? We've got y is equal to minus 2x over t, plus 2 minus t squared over 4. So I just expanded the bracket, the t's cancelled, it was plus 2, and then move this over to become plus t squared over 4. So this is the normal at Q. Okay, now the normals at P and Q intersect at R. The line RQ is perpendicular to RP. RQ is perpendicular to RP. Okay, so we better draw it to see exactly what we've got then, haven't we? So here's our sketch then. We've got y equals a half x squared. Let's just, draw it in. It's a U-shaped quadratic curve. P is at 4, 4, so we'll draw it here. And it's got a normal here and a tangent here, say. And this is the point P. Now the normal at P and the normal at Q intersect at R. And the line RQ is perpendicular to RP. So it looks like if I draw a perpendicular line here, so R is where they meet, and RQ is perpendicular to RP. There's Q. So this line here is perpendicular to RP. We've got a tangent, of course, here at Q as well. Okay, good. So they meet at R, and we've got that. So we know this gradient here of this line is 2, don't we? We know this gradient here is equal to minus a half, because it's perpendicular. That's a right angle there. And then the gradient of this line is equal to, must be parallel to this line, badly drawn I know. So that gradient is 2. So here, if the gradient is 2 of this normal, and minus 2 over t is the gradient, isn't it? Is the gradient, minus 2 over t. Now that needs to equal the gradient of this, 2. So that tells us that t is equal to, move the t up, move the 2 down, minus 2 over 2 is minus 1. So Q has coordinates then, minus 1. And minus 1 squared is 1, over 4 is 1/4. So there's Q, which is what we wanted to show. Find Q. Find the x-coordinate of R. So the x-coordinate of R here. Okay, so when do these lines meet? Well, first of all, this equation here, when t is minus 1, this is the equation of this line. So here, y is equal to minus 2x over minus 1 is 2x, plus 2, plus t squared over 4 is 1/4, isn't it? 2 1/4 is 9 over 4. So there's the equation here. This line is the normal, which we got before, which was y equals minus a half x plus 6. So here, to find the x-coordinate, we just let the y's equal then, don't we, at R. 2x plus 9 over 4 then is equal to minus a half x plus 6. Move this over, 5 over 2x, 2.5x. When we move that over to plus, 6 minus 9/4. 6 over, as quarters is 24/4, isn't it? Minus 9 is 15/4. So cancel by 5, cancel by 2 both sides. So x is equal to then 3 over 2. And that's the value, the x-coordinate at R. So that's that part done. Find the x-coordinate at R, that was part C. So this was part C. This was part B here. Okay, good. Part C is done then. The tangents at P and Q meet at S. So here's the two tangents and they meet at S. Show that RS is parallel to the y-axis. Show that RS, this gradient here, is parallel to the y-axis. Okay, well this has a gradient minus a half because it's the tangent. And this has a gradient 2. So we've got a square, haven't we? Okay. So the x value is where the tangents meet, and the x value here was 3 over 2 at R. So all we need to do then is find out the x value at s. So at s, so first of all this tangent here is y equals 2x. Now the equation of the tangent was, let's just go back up and get it, minus 4. And the other tangent is equal to y equals this tangent here, it's y minus the x value at q. Now q has coordinates minus 1, so y minus minus 1 is y plus 1, is equal to the gradient, minus a half, times x minus dx. Oh, y minus a quarter. Yeah, I shouldn't have put that, sorry. So let's just change that again. Y minus the y value at q, which is a quarter, is equal to the gradient minus a half, times x minus the x value at q, which is minus 1, makes that a plus 1. So that tells us then y is equal to minus x over 2, plus a quarter minus a half is minus 1/4. Plus a quarter minus a half is minus 1/4. So there's the two tangents. So here the x value then will be 2x minus 4 is equal to minus x over 2 minus 1/4. So what do we get then? Move this over, 5x over 2. Move this over, 16 plus 1 is 17. No, 16 minus 1 is 15, that's it, sorry, over 4. The 5's cancel to leave 3, the 2's cancel to leave 2. So x is equal to 3 over 2. So RS and S both have x coordinate 3 over 2. Consequently, the line RS is parallel to the y-axis because they both have the same x coordinate. And that's what we wanted to show. And I think, just check, that's the end of the question. Yep. Okay, good.